Hello student, today we are going to start our next topic, that is projectile motion, which is very important topic for the class 11th. See, first we will try to understand what actually projectile means. See, projectile means any object which has been thrown into the sky and it moves under the action of gravity only. It has no engine or fuel. It moves under the action of just gravity only. And while deriving formulas for height, range and time, it has been assumed that assumption has been made in projectile motion that there is no air friction. There is no air friction. The effect of curvature of Earth has been not taken into account. Curvature of Earth has not been taken into account. Third, the rotation of Earth has no effect. Rotation of Earth has no effect on it. See, we will do two types of projectile motion. First, that is horizontal projection. See, basically we have horizontal projection. See what we have. The body is thrown. This is x-axis. This is y-axis. The body is thrown from this height, and it is acting under the action of gravity only. Gradually it comes to the ground like this. So at any point of time, let us suppose it has traveled distance x along the x-axis and this is y along the x-axis. See, distance y along the y-axis. X is what? It is basically, we know that it has velocity u. X is what? Displacement is what? Velocity into time. So time is coming out to be what? X by u. Then we go for like y. Y is what? U y t plus half a y t square. See what we have in horizontal projection. What we have u y as 0. Then it becomes what? Y. This is half, and a y is what? It is only acting under the action of gravity. So a y becomes g, and this is t square. See what we do is that suppose we place the value of t over here. It is coming out to be x square u square. See what actually it is? It is half g by u square into x square. This is y is equal to kx square. See, it is the equation of the parabola. It means that projectile follows parabolic path. This is case of horizontal projection. Projectile follows parabolic path. Then we come to, let us suppose it has, this is the ground over here. The distance to the ground is like h. So y is what? uyt plus half ayt square. So what we have, this is h, uy is 0, this is half, this is gt square. This is the height of the projectile. From here only we can get the time. It is coming out to be what? 2h upon g root. This is the time of the projectile, and the range is what? The distance moved along the x-axis. This is the range. It is equivalent to what? Velocity into time. This is u. Velocity is what? Root over 2h by g. Now we calculate velocity of projectile at any instant of time. See what we have. Let us suppose we are calculating the velocity at any instant. This is, let us suppose, vx, this is vy. We know that this is what? Velocity of projectile at any instant of time. See what we have. Velocity along the x-axis, vx is what? Ux plus ax into t. Vx is what? Ux is u, and we know that it has no component, no fuel, no acceleration along the x-axis, so Vx is u. Then we have like velocity along the y-axis what? Uy plus ay into t. Since it is horizontal, case of horizontal projectile, we don't have component along the y-axis, and ay we know it is only acting under the action of gravity only, so Vy will be equivalent to what? G into t. And we know that these are perpendicular to each other. The resultant velocity will be equivalent to what? That is Vx square plus Vy square. Vx is what? This is u square, and Vy is gt. This is g square t square. This is coming out to be what? U square, g square, t square. Then we will find the angle at which projectile strikes the ground. See, let us suppose this is angle beta, this is tan beta, this is perpendicular Vy, and along the base we have x, Vy upon Vx. Vy is what? We have, this is gt, and velocity along the x-axis is u. This is angle at which projectile strikes the ground. Angle at which projectile strikes the ground. Now we will move on to case of angular projection. See, in the case of angular projection, it will have like, it will be thrown at certain angle. This is case of angular projection. This angular projectile. See what we have. Let us suppose it makes angle, see, this is velocity u, and it makes angle theta over here. The component along the x-axis is what? Velocity, initial velocity along the x-axis is what? It is u cos theta, and velocity along the y-axis is what? U sin theta. And we know that since it is a case of projectile, we don't have any acceleration along the x-axis, and acceleration along the y-axis is g. See what we have. Let us suppose this is what? X. So x is what? X is u cos theta into t. T is what? X upon u cos theta. Basically it is a distance traveled. Distance traveled is equal to velocity into time. So I have taken any point which is xy over here. Now we will go for y. Y is what? Uyt plus half ayt square. So what we have? We know that uy is this, y, this is uy is u sin theta, and t is how much? This is x upon u cos theta minus half, because acceleration is negative. T is what again? X square u square cos square theta. It is coming out to be this get cancelled out, this becomes what? X tan theta minus half g x square u square cos square theta. Basically it is what? X va plus c x square. See, basically it is a equation of parabola. So there is quite similarity between these two, is that they both have parabolic path. Now we'll go for, means in angular projection also we have parabolic path. This is equation of parabola. So it follows parabolic path. Now we'll go for calculating height, range, time of the projectile and velocity of projectile at any instant of time. Now see what we'll do. See, what we do is that, let us suppose a body has been thrown with the velocity u, this is theta. So why it is not able to go forward? Because we know that component which is led to rise above along the y-axis, Vy is what? This is Vy is what? Vy is equal to Uy plus Ay into t. Vy is what? U sin theta. It is going upward. See, at highest point, what has happened is that the velocity component Vy has become 0. So we have U sin theta gt. This is what? T is what? U sin theta by g. See, it is time taken by the projectile to reach the highest point. And we know that whatever the time it has taken to reach the highest point, time of ascent is equivalent to the time of descent. The total time of flight will be equivalent to 2t, this is 2u sin theta by g. Now we will go for height of the projectile. How to get that? Height is basically distance moved along the y-axis. This is height. It is y is what? U by t minus half a y t. We can write plus, since it's going upward, doesn't matter, we'll be able to calculate that out. T is how much? To reach the highest point we have u sin theta by g. Then we are going upward, ay is minus g, and t is again u sin theta upon g whole square. See, it is coming out to be what? U square sin square theta, u square sin square theta g minus u square sin square theta by 2g. It is coming out to be what? This is 2u sin square. We are getting u square sin square theta by 2g. Suppose we want height maximum. In that case, it will be u square by 2g. In that case, sin theta will be equivalent to 1, and this will occur at theta is equal to 90 degrees. Now we will calculate the range of the projectile. For the range of the projectile, we see that what we have, this is the range. Range will be equivalent to what? It is velocity component along the x-axis, or ux into the total time of the flight. So what we have, this is u cos theta at time is what? U sin theta by g. So what we have, u square, this will come 2 sin theta into cos theta upon g. See, we know that according to trigonometry, 2 sin theta cos theta will be equivalent to sin 2 theta upon g. This is r. And suppose we want to go for like, here, this is 2 theta over here. Suppose we go for the range maximum, it says that it can only occur at what angle? This is sin 2 theta when it will become maximum. 2 theta will be equivalent to 90 degree, theta at 45 degree. In this case, what will have? We will have maximum range of angular projection when the angle it makes with the ground is 45 degree. Now we will go for velocity of projectile at any instant of time. velocity of projectile at any instant of time. See, in this case what we'll do is that we know that, let us suppose this is Vx, this is Vy, this is Vx is what? It is u cos theta, and we don't have any acceleration, so it does anything. Along the Vy is what? We have u sin theta, acceleration along the y-axis is gt. So the resultant velocity will be equivalent to what? Vx square, Vy square. So it will come out to be what? U square cos square theta plus u sin theta minus gt whole square. Then we will go for angle at which projectile strikes the ground. Angle at which projectile strikes the ground. See what we have in the case of projectile striking the ground. Let us suppose this is beta, the angle at which it strikes the ground. What we have? This is Vy and this is Vx. We have like 10 beta will be equivalent to what? Vy upon Vx. Vy is what? It is u sin theta minus gt, and Vx is what? U cos theta. So these are the few important topics related to the projectile motion. We have to take into consideration that projectile is basically those objects which has been thrown into the space and it is acting under the action of only gravity. There is no fuel for the projectile, there is no engine. Then only, and it has been, assumption has been made while deriving all this thing that there is no air resistance and the curvature of the earth has no effect on it, and as well as rotation of earth is not going to affect anything. Assuming all these things, we have derived this formula. That's all for today. We'll meet in the next class. Thank you.